So welcome to this WiseOwl tutorial on error trapping in Python. Here's what you'll learn during the tutorial. So we'll begin by looking at an error example, easy enough to create, and then we'll look at how you can do error trapping, basic error trapping in Python, before looking at specific error trapping, so trapping things like divide by zeros or type errors. We'll then look at how errors bubble up from functions into calling code, and then we'll look at how you can return an error message from a function, which turns out to be a bit harder than you might think. We'll look at how you can raise your own errors, as if built-in errors weren't enough, and why you might do this. And then, for completeness sake, we'll look at the else and the finally clauses, just to show everything which is possible. And finally, we'll look at the rather heretical question of whether error trapping is actually worth it, and what the alternatives are. At the top right of your screen about now, a link should appear, and you can click on that to download any files to do with this tutorial. If it doesn't appear, you can get them from the YouTube site. There's a link there too. But as always, I'm uncomfortable being on screen, particularly with this jungle behind me. So what I'm going to do now is to disappear and hand control over to the ever-loyal Sven, who will guide you through the rest of this tutorial. So let's get started. Before we look at error trapping, we need to actually be able to generate an error to trap. So what I've done is I've created a folder called error trapping and a file called badcoding.py, which gives you some idea of the quality of the program we are about to write. So what I'm going to do is we're going to create a function to calculate the reciprocal of a number, and I'll call it reciprocal. And it will take in a number. And let's say we can have any floating point number, and it will spit out another float, we hope. And then within the function, what it will do is return 1 divided by the number. And any programmer should immediately start having, I don't know, it's like someone walking over your grave. You just don't do 1 divided by a number without first checking for divide by 0 errors. So let's see if it works. If I print out the reciprocal of, say 10, that should give me 0.1 because that's 1 over it. And it does, 0.1. So that's great. Let's try the reciprocal of 0. 1 divided by 0 gives an error. Specifically, it gives a 0 division error. There's different types of errors generated by Python, and that's one. Let's look at another. Let's try taking cheeseburger as the input, and that will give me a type error. So I've managed to create a function which actually allows at least 2 possible types of errors. And what we're now going to do is we're going to trap for that. And before we do that, let's look at the syntax of error trapping. So looking at the syntax of error trapping, we've got here a dodgy statement. It's trying to print out 1 divided by 0. To error trap something, you precede it, or you precede the dodgy thing you're trying to do with the word try followed by a colon. If I was to run this program as it stands, it would give me an error message because try has to be accompanied by except. And in the except clause, you take some remedial action, whatever that may be. In this case, it might be printing out a message saying that you can't divide by 0. There are other words you can use like else and finally, which we'll come to towards the end of this tutorial. And you can also test for different types of errors, but that's the basics of it. So let's put this into practice in our code. What we'll do is add some error trapping before our offensive or potentially offensive statement. Later on, we'll see that it might be better to do this within the function, but for the moment, we'll just put it in the main body of the program. So to do this, we'll trap possible errors. And to do that, I can just put the word try in, followed by a colon, and then need to indent everything which follows it. And I need to put in an except clause. And in the except clause, I can say what happens if things go wrong. So I'll just print out, in this case, something went wrong, which is a nice vague error message. So if I try running that, you can see I get the message something went wrong because you can't take the reciprocal of a cheeseburger, but you can take the reciprocal of 42. So if I run this again now, it will give me the reciprocal, which apparently is that number. So that's basic error trapping. Let's look now at how you can trap different types of errors. So just before we look at catching specific types of errors, a quick reminder of what the errors we might generate are. Here I'm trying to print out 1 divided by 0. If I run this program, I will get a 0 division error. If I comment that line of code out and instead try to divide 1 by a bit of text, then I will get a type error. So those are the two specific errors we're going to trap. And to do that, you can change the word except, and after it, type in the specific type of error you're trying to trap. I wanted a divide by 0 error. I can't already remember what that was called, but if I type in div, providing I don't type any more than that, you can see 0 division error is one of the possibilities in the list. So it's trying to help you. So I'll choose that and put a colon after it. And if there's a 0 division error, I'll print out a message saying can't divide by 0. Otherwise, the next type of error I'm going to trap is a type error, and this one I can remember. And if that's the case, I will put a message saying make sure you use a number. Now if I get to this point, I know I didn't have a 0 division error, and I didn't have a type error either. But it's still possible my program could have crashed. So I'll just make sure by putting in a general except clause to mop up all other possibilities. And in this case, I'll say something else went wrong. At the end of this tutorial, I'll come to a question whether error trapping is actually worth doing or not. A very heretical question. So let's try running that. If I run that at the moment, it will give me the reciprocal because there's nothing wrong with taking the reciprocal of 42. If I change that to 0, I'll get can't divide by 0. And if I change that to a bit of text like Bob and try running that, it will give you make sure you use a number. I can't think of a way of generating any other type of error, so I don't think I'm going to be able to test my final statement. So that's how you can test for specific types of error. So all of the examples we've done so far have used a concept called error bubbling. The error which is happening is occurring within the function itself. That's where it's crashing. But because that doesn't handle the error, it's bubbling up, it's being raised up to the calling function. Unfortunately, that does handle it. Now there's a good argument for saying you should always handle errors at the level at which they occur. The problem with the approach I've taken so far is that while this is well-behaved code, some other less enlightened person might call my reciprocal function and not handle the error which occurs. And in that case, it will just crash. Whereas if I had the error trapping occurring within the function, I wouldn't have that problem. So I've created a separate file called noerrorbubbling.py, in which I'm going to try to show this principle and talk through some of the issues involved. So I've created my function within that, and I'm going to add error trapping to it, which you do in exactly the same way. So I'll put a try statement in, and if it's all good, I'll return 1 divided by the number. And then I'll have a general except statement. So I won't bother catching the specific type of error. But the question then is, what do I do if it crashes? What do I return? I guess what I would like to do is return an error message, but I've already said that this is returning a float, and I don't really want to lose that strong typing. So instead, what I'll do is print out an error message here saying what my problem is, which is that I cannot create reciprocal. And then I will return, I've got to return something. By default, it will return none. Let's make that specific. None, of course, is a special Python keyword, which means it's like a null value in other languages. So now I can try testing this out, and I can print out the reciprocal of a number. So I'll start with something nice and easy. I'll print out the reciprocal of 2. And if I try doing that, you'll see it gives me 0.5. If I try the reciprocal of 0, it will print out the message cannot create reciprocal, and then return none. So at this point, I would probably then have to, rather tediously, create a variable called answer, set that to be the reciprocal of the number, and then check whether answer is none. And if it is, I guess I won't do anything. I'll put in a pass statement just to say I'm not doing anything because I've already printed out my error message. Otherwise, I will print out the answer. So if I now try running that again, I will get cannot create reciprocal because I can't. But if I put in a valid number, then I'll get 0.5. That was all quite messy and involved quite a lot of extra lines of code. Is there a better way to do it? The previous example printed out the error message from within the function itself. But what would be nice to do is to pass back the error message to be displayed in the calling program. There are a couple of ways of doing this. There's raising events, which we'll look at in a second or a minute. But firstly, we're going to look at returning an error message from a function. To do this, what we'll do is pass a string variable into the function, and if an error occurs, we'll set the string variable to be the message to be displayed, and then try picking that up in the calling code rather. This won't work, and the reason is strings are immutable, but I want to prove this to you. And then we'll look at a fix to get around this by making it a mutable object. And you might like to think what that would be. So firstly, we're going to create a variable, let's call it error message, and set that to be the error message to be displayed. Initially, there isn't one. And then I'll create a variable called answer, and I'll call my reciprocal function, and I'll pass in two things. I'll pass in the number I want to take the reciprocal of, and the error message variable. And then, after running that, I can test whether an error occurred. To do that, I can look at the length of the error message, and if the length of the error message is 0, it means no error occurred, and I can happily print out the answer. Otherwise, I can print out the error message which I set. It's all looking very logical and sensible. It's a shame it won't work. Within my reciprocal function now, I could pick up on this error message argument passed in. Remember that I can call these anything I like, so I'll call it something different just to emphasize that fact. And I can basically add my error trapping. And if anything goes wrong, what I'll do is set my error message to be, I'll just say something went wrong. Clearly, you could make this more specific and trap different types of errors to return different error messages. And then I'll have to return something, and what I'll return is none. In fact, whatever I'm returning is never going to be picked up on because I know an error message occurred. So that should work. If I now try running that, you should see I get 0.5 because that was all okay. But if I pass in 0 as my number to take the reciprocal of, it gives me none. What it doesn't do is print out the error message. And the clue as to why that isn't working is the fact the word error message appears in grey to show it's unused. And just to emphasize this point, what I'm going to do is set a breakpoint on this line, and then try running my program with the F5 key. So when I run it, you can see it has gone to my breakpoint. It has set the value of my error message variable, but when I return back to my calling routine, it's not being passed back. And the reason for that, if I just stop that and get rid of my breakpoint, is that strings are immutable. You can't, once you've set the value in a string variable, you can't change it, whether that be in the main program or in a function. And to me, this is a bit of a limitation of Python. Other languages allow you to pass variables by reference, but Python doesn't. But there is a way around this, which is maybe a bit of a fudge, I don't know, see what you think. The way around this is to change this variable to something which is mutable. And the obvious thing which springs to mind is to create a list, a blank list. Now I've changed my variable name to error messages because I like my list to be plural. So I'll just need to go through and change that wherever it occurs. And what I'll also do is change my argument name to error messages. So I'm passing in a list. In my function, when I get an error, I can now append onto that. I just need to change this to say it's a list being passed in, not a string. That's why I wasn't able to append to it there. So I can now append my error message to be displayed. And back in my calling program, I can say if the number of error messages set is 0, I'll print out the answer. Otherwise, I won't print out the whole list. I'll just print out the first item in it. Because most times when something goes wrong, it'll just be a single message which is returned. So now if I run that, you'll see I get something went wrong. Much better. And if I run it with a normal value, I'll get the reciprocal of it. One of the advantages of this approach is I could potentially append more than one error message, so I can return a whole list of things which went wrong, which is quite a nice idea. I often find, particularly if you're doing validation of a user's form input, it's quite useful to say, well, you didn't do this, this, and this, rather than just returning the first error message, leaving them to solve that, and then irritatingly have to solve the others one by one. So that's one way to get around the problem. Create a mutable variable and pass that in and set it within the error handling routine. The other way is to raise errors, which we'll look at now. So we're going to look now at another way to make the reciprocal function bulletproof, and that's to raise an error or an exception within that and handle that exception in the calling program. So I've created a file called raisingErrors.py, and before we just do this, can I just show you what raising an exception involves? You can type in the word raise exception, and then in brackets you can specify what the problem which has occurred is. It's always a good idea to make this as scary as possible, so I'm going to put the hard disk has crashed. If I now run this program, it will raise my exception. So as if the built-in Python messages weren't scary enough, you can add to them with your own almost infinite amount. So that's how you raise an exception. Let's now put this into practice. So in my reciprocal function, I'm going to try doing something. The thing I'm going to try doing is returning the reciprocal of the number I passed in. And then I'm going to have an except statement which raises an error. So I'll raise an exception and it will just say problem occurred. In practice, what you would do is have different except lines for a divide by zero error and a type error, and you would return different messages for each, but that will do for now. So back in my calling program, I can test this out. And I can print out the reciprocal of 0, which of course will return an error. Now this should still crash, and the reason is it's gone into the error handling here and raised an exception, but that hasn't been handled either, so I've got two problems occurring. So what I need to do if I'm going to go down this route is I need to do error handling within my calling statements as well. What I now need to do is, if an error happens, I can print out what the exception is. Now, rather than just printing out the single exception, I'm going to show you how to actually pass out more than one bit of information. So we're going to say a problem occurred, and then we're going to say what it is. So it's probably a divide by zero error, just to be helpful. In my except statements, I can use this syntax. I can refer to my exception, and I can give it an alias and call it problems. And then in my error handling here, I can say list out the problems. To do that, I say for, let's call it P in problems. And I actually have to put problems.args. For some reason, you have to get at the underlying args property of it to list out all the different problems which have occurred. So now what I could do is print out that problem. What I should get now is when I run this, I will get two error messages, one saying problem occurred and one saying probably a divide by zero error. And there it is. But if I try to do an OK reciprocal, I won't see any of that. I'll just see the reciprocal itself. So that's another way to solve the problem. Again, it has the advantage that I have complete control over the exceptions passed out. Possibly the best way of doing error trapping? I'm not sure. Judge for yourself. In the interest of completeness, there's two other statements you can use in a try block. They are else and finally. And it's easy enough to understand how they work with an example. So let's go back to do our usual example of printing out the reciprocal of a number. But before we do that, we're going to put in a try statement and then try printing out the reciprocal of 0, which will definitely give us an error. I can then put in fact, I have to put an except statement in, and the except statement will just print out that there's been a problem. Good. What I can then do is include an else statement. And this curiously worded statement will mean any command within this will run if no error occurred. So I could print out worked okay. And finally, I can put, and sorry about the pun there, I can put a finally statement. And this will run whether the statement crashed or didn't. So under all possible circumstances. So in this case, I'll say that's it. Okay, let's try running that for two possibilities. One is I've got an error, the other is I haven't. So the first time I run it, I've clearly got an error. It's going to print out the message problem occurred. And then it's going to go to the finally statement, which it always runs, and say that's it. So let's see if I'm right about that. I am. Good to hear. Now let's do it with one which will work. So I'll print out 1 divided by 2. And in this case, everything will work perfectly. So we'll print out 0.5. It won't print out my exception, but it will print out, go to the else statement and print out worked okay. And then I'll get that's it. So if I run that, you'll see I get 3 things printed out. At this point, you may, like me, be wondering what on earth the point of the else and the finally statement is. For the else statement, what's the point of including statements in a separate block when I could have just put them in my try block? And for the finally statement, what's the point in doing this when I could have achieved exactly the same effect by putting them at the end of my code like that? Now, perhaps I'm not the best person to answer this question because I'm a bit of a Luddite on error handling in the first place, but I really can't see the point of those 2 extra blocks, and in general, I don't think you'll need to use them. So I'm just going to revert back to my previous position. So that is the full try statement. So I want to end this tutorial with a completely heretical question, which is error trapping actually worth it? Now, at this point, many experienced programmers will probably turn their machines off in disgust, but it's a legitimate question. I've written many systems, and I don't tend to put error trapping in them. And the reason I don't is because once I've thought, well, an error could occur here, then I avoid it occurring by putting in validation. And maybe I'm missing the point about this, maybe I'm not a purist, but it's certainly worth having the discussion. So what I've done is I've created a file called wasitworthit.py. And what I'm going to do is show you how I would write this function. There's 2 possible errors which can occur. Let's solve them both in succession. So the first error which could occur is I'm not passing in a number. Well, that's easy to solve. Let's check if it's a number. And to do this, I can say if the type of the argument I passed in is a float, or type is a number, or is an integer. I need to check both. Then I've definitely got a number. And what I'll do is I'll create a variable called test number, and I'll convert whatever I've passed in to that. So the result of those lines of code is that I've definitely got a number. Of course, I need to put an else condition now saying, well, if it wasn't a number, what I'll do is print out an error message. I'll say not a number, and I'll return the value none. So that's my first check. So I now know I've definitely got a number. The next thing I need to check is for a divide by 0. And to do this, I can say if my test number, which I've just created, equals 0, then I need to print out I've got a divide by 0 error, and then I can return none too. Finally, if I get down to this point, I know that I've definitely got a number, and I can return the reciprocal of it. Now, I cannot imagine a circumstance under which this would go wrong. I guess I could pass in some complex number or some weird date, but in practice, am I really going to do that in my code? Let's see if this works then. I'll test this out. So what I can do is create a variable called answer, and I'll start with something which I think will work, the reciprocal of 2. And I can say if the answer returned is none, then I have a problem, and it will print out that error message. So I'll just put pass in there. And what that will mean is it just won't do anything. Otherwise, everything worked okay, and I can print out the answer. I'm running that, and it gives 0.5. Everything worked perfectly. But if I now try doing that with something which won't work, let's start with 0, which is the second error which could occur, then it correctly interprets 0 to be a number, but fails at the second hurdle and prints out divide by 0 error. If, on the other hand, I put in a bit of text in here. Let's go for the ever faithful Bob and run that. I get not a number. So without any error trapping whatsoever, I've got a reciprocal function which I can use, I think, in all possible circumstances. And that's the approach I take. I have very little error trapping in my code. But as I say, it may be that I've just lost half my viewers, I don't know. But it is surely a discussion worth having.